Hey there, this is Math Foundations 10. This is the second chunk, and we're talking about radicals. I'm sorry they're not as nicely numbered and organized, but the students and I are co-piloting this way of going through this material this year, so it's work in progress, as we all are. Anyway, but before we do radicals, I want to finish the very end of the previous page. And because this follows through to what we're doing next on radicals. Okay, so the decimal value of 1/3. Some of you probably know it. I go 1 divided by 3, I get 0.3. Now, for some of what we're doing, that's probably good enough, but this is not exactly the same as this, right? Because we got all these other 3's. And so maybe you're used to doing this because this would make me very, right? The last thing I want you to do is to write out all of these. That's a waste of your time. And I'm just going to look at it and go, seriously? I don't need that many decimal points. And the reason we get this, now I have to think hard on how to do this. Shh, if I get it wrong, don't tell. Okay, if I get it wrong, shh, don't tell anybody. I think this goes, 3 goes here, and the 1 goes here. We're going to do long division. I hate long division, but there's a point to it. Okay, so 3 doesn't go into 1, so it goes 0. 0 times 3 is 0. Decimal comes up. Put that, I'm going to bring it down there. 3, I think that's how that works. It's been ages. 3 into 10 goes 3 times. 3 times 3 is 9. That leaves me 1. Put another 0, bring it down. 10. 3 into 10. Woo, goes 3 times. 3 times 3 is 9. Are you okay? I'm running out of room. You see what's going on? That's why it's the repeating 3, is because when you do this, there's always a 1 left over, so you can always keep going. If I did, instead of 1/3, what if I did a half? Well, that's going to be the 2 goes here, the 1 goes here. Again, doing long division. 2 into 1 doesn't go. 0, 1. Bring down a 0. 2, whoopsies, bring down a 0. 2 into 10 goes. Sorry, yes, 2 into 10 goes 5 times, which is 10, and 0, and we're done. That's why it's not 0.5555. We're done. Finished. This sucker, never. That's why it's a repeating decimal, and mathematicians usually write it like that. Okay, so if I don't know, you know what? If I'm doing a recipe for a batch of cookies and I need 1/3 of a cup and I just estimated that is 0.3, it's close enough. Well, truth is, I probably have a measuring cup that says 1/3. But if I was making 1,000 batches of cookies and I just use this estimate, you know what? My recipe may be off. Or if I'm building a road and it's going 30 miles, well, that little bit of a difference here between this and 30 miles might mean my roads don't connect anymore. So sometimes we need exact values. That's my point. Sometimes not so much. And now on to today's lesson. Okay, radicals. Radicals. Where's my picture? Okay. Radicals are a subset of irrational numbers. So over here. Let's get rid of that diagram. The numbers under the square roots are not perfect squares. So all the stuff we did before were nice perfect squares. Now, let's do the square root of 12. And on my calculator, I get 3.4 6, 4, 1, 0, 1, 6, 1, 5. A lot of numbers. Now, if I do the same thing on my phone, let's see if it'll work. Come on. There it is. Okay, see, there's the square root button. It's got the little 2 there. So square root. Oh, no, my calculator's backwards. So I got to go 12 and then square root. See what happens? Hold on. 3.464 101 615 13775. Okay, I don't, well, can't see it. That's just way too many numbers. Okay. So this, my point is this is my calculator gave me, but my phone, because it carries more decimal points, there are more after that. So this is an estimate. A pretty darn accurate one, but it's an estimate nonetheless. This too is an estimate. More accurate because there's more decimal places. Right? If I take, oh, hey, I'm going to try something. 3.464 101 615 and I square it. Hello, where's that button? All right. Yeah. Okay. Never mind. Not my regular calculator. I was just going to square it, not swear it. Square it to see how close it came to 12. The point of this is the calculator is giving you estimates. Sometimes you need the exact value. Just like sometimes you need 1/3 to be like 1/3 or 0.3 repeating, not just 0.3. And when are those sometimes? Geotrig, pre-calculus, calculus, engineering. I'm going to guess computers. I don't know, maybe business, but I doubt it. Anyway, it's not hard. You're going to learn it today. So to take this radical and simplify it, that's what we're going to do. What you do is you start with the ever so popular tree it out. 4 times 3, 2 times 2 times 3. You should be bored. The other ones that we did, when they were perfect square roots, you would have a pair and another pair. Well, we don't. So these two are a nice pair. This is the leftovers. So what you get is 2 square root 3. So 1 from the pair comes to the outside. Just like the square root, you would take 1 from each of the couples that you circled, and the leftovers stay behind. Okay, ta-da. So step 1, tree it out. Okay, we all know that means prime factorization, but it's easier. 2 circle pairs. 3, 1 from each pair goes outside. Leftovers. Stay in. And 4 is simplify if we can. If possible. Okay, so my stupid story for this is like these guys, young and in love. These two, they act as one. Hang out together. They do everything together. And this one stays behind. That may be sad. Somebody says like cards, but I like my silly stories. Okay, let's do it again. So 20, 5 times 4, 5 is prime. Break this down, 2 and 2. Circle my pair. Pair goes to the outside. 2. Leftovers. 5. Done. End of story. Essentially, and this is the way I used to teach it, what you're doing is you're just taking out the square root part. So the square root of 4 is the 2, and then the 5, you can't take a square root of it, so it stays under the root sign. And that's all there is to it. So let's quickly run through these last ones. All right, so 81 is 9 times 9. And some of you possibly are yelling at me already going, yeah, square root of 81 is 9 and we don't need to do any more work, but I want to prove my point. And I could give you a test question that says prove it. So you have to be able to do the work. Circle my pairs, circle my pairs. So then we get 3 comes to the outside from here. And 3 comes to the outside. And there's nothing left under the root sign because there's nothing that isn't circled. And ta-da, that's 9. End of story. All right, square root of 35. It's 5 times 7. Ew. Ew. All right, well, there's no pairs. So we end up you don't really need this step, but I wanted to show it because it follows the pattern. Okay, so these didn't have partners, so they stay underneath the root sign. And just a minute. All right, sorry about that. All good. I hope that as I had that little pause, you said, hey, I get this. I'm going to keep going. All right, let's do 320. Oh, big number. But let's cheat. 0 on the end. I know that 10 is one of the factors. And 32. You can go 320 divided by 2 and then divide by 2 and it 10's faster. Because then my numbers are small enough, I can do them in my head. So 5 and 2 and 32. As she has to think, how about 8 and 4? So 5 comes down, 2 comes down, 8 comes down. That's not prime. 4 and 2. This breaks up. 2 and 2. Almost done. Can you still see it? Move it up, move it up, move it up. 5 and 2. Break it down. 2 and 2. And another 2. And another 2. And another 2. Now I know 32 is 1, 2, 3, 4, 5. I better check. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 32. 5. Yeah, we're good. Check it out. There's a pair. There's a pair. Yes, there's a pair. So that means a 2 and a 2 and a 2, 1 from each pair. Comes to the outside. Leftover is my 5. 2 times 2 times 2 is 8. Careful, you're multiplying. Remember that. Root 5. Now, let's see if this works. And sometimes your fancy schmancy calculators, one I have at home. Oh, it's really hard to see. Neat, neat, neat. Put it over there. I can actually punch this in and it will take me to this part. And if you have one of those, that's wicked awesome. But I'm still going to ask for the work. So I'm going to go square root 320. And I'm just going to write 17.88. It's 88 something. I don't care. I just want to see if I go 8 times root 5. So 8. Now, I'll try this. Root 5. Woohoo! Look at that. Look, 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 look. I didn't even have to hit the multiply button. That is 17. That was the same number, 17.88. And I know I didn't round properly, but it's okay. It's okay. Let's move this. So we're golden. So that's what I'm saying, is that this and this are exactly the same value. This is just a simplified radical. Thank you. And I hope you have a lovely day.